Today's session is about Lagrange's linear partial differential equation. First, we have to rewrite the equation in standard form. Capital P small p plus capital Q small q is equal to R, where small p and small q are dou z by dou x and dou z by dou y respectively. Capital P and capital Q are their coefficients. Next, we have to form an auxiliary equation, that is dx by p is equal to dy by q is equal to dou z by R. Then we have to solve this equation to find two independent solutions, which can be done by taking two fractions. Here three fractions are there, any two fractions we can take. We can take this or this and this, any combination we can take. And solving this equation can be done in three ways. One, by grouping method. Second, first we find one solution and with the help of that solution we can find the second solution. And third method is method of multipliers. That is, here we make new fraction in auxiliary equation with the help of multipliers. We'll understand this in detail as we proceed. Now, after solving the equation, we get two independent solution. U of this is equal to C1 or V of this is equal to C2. C1 and C2 are integral constants. Now here u and v are linearly independent. That is, u by v is not equal to constant. Now after we get two independent solution, we have to form general solution. General solution can be written in this way, either this or this. In this video, we will be discussing case 1 and case 2. In the next video, we will discuss case 3. So here case 1 is grouping method. Here we have to make pair of integrable fractions pair we have to make with the help of or from existing AE. If all the three pairs are integrable, then we can choose any two of our choice. Let's see some example. Let's take this equation. We'll name it as equation 1 and then we have to put it in this auxiliary equation format. So here dx, so we have to dx as such, and capital P is coefficient of this P, that is tan x. Similarly, dy by coefficient of this Q, tan y, and dz equal to this value. Now here we'll call this equation as equation 2. Now here we'll take first and second fraction, these two. 1 by tan x can be written as cot x, 1 by tan y can be written as cot y. So we'll write cot x dx is equal to cot y dy. On integrating, the cot x becomes sin x, log sin s, and cot y becomes log sin y. Plus integration, we have to add one integral constant. So that is C1, we can write log C1. Now bring this log sin y this side. So it becomes log sin x minus log sin y. According to the log property, it can be written as log sin x by sin y is equal to log C1. So this log and this log get cancelled. We'll get sin x by sin y is equal to C1. This we'll call it as solution 1. Now we'll take the fractions 2 and 3, second fraction and third fraction we'll take. So 1 by tan y is cot y, 1 by tan z is cot z. Integrating it, we get this. So bring this log sin z this side, and using log property, we get this. So here log and log will cancel. Answer we'll get as sin y by sin z equals to C2. This is solution 2. Now we got solution 1 and we got solution 2. So we can find general solution. Psi is equal to solution 1 comma solution 2 is equal to 0. So solution 1 is sin x by sin y. Solution 2 is sin y by sin z. So we got this required general solution. Now let's take the example, this example. Here let's call this as equation 1. We have to bring it in this auxiliary equation form like this. Here capital P is x square, y square and z square. We'll take fraction 1 and 2. So fraction 1 and fraction 2. On integrating, here dx by 1 by x square, 1 by x, integration of 1 by x square is minus 1 by x, integration of 1 by y square is minus 1 by y, plus integral constant, we'll take it as C1. So bring this term here. So we get 1 by y minus 1 by x is equal to C1, and this we'll call it as solution 1. Now we'll take fraction 2 and 3. So integrating it, we get minus 1 by y is equal to minus 1 by z plus C2. This C2, any constant. So bring this z this side, 1 by z this side. So we get this answer. We'll call it as solution 2. So general solution will be solution 1 comma solution 2. So this is the required general equation, general solution. Now take this example. Here we'll call this as equation 1. We'll put it in the auxiliary equation format. So dx is equal to yz is equal to dy is equal to zx is equal to dz is equal to xy. So we will take this. Now here we'll take fraction 1 and 2. So we have taken fraction 1 and 2. Here z, here also is there, z is there, here also z is there. So these two will get cancelled, we'll get this. Bring x here, bring y here, we get this. On integration, we get x square by 2 is equal to y square by 2 plus c1 by 2. We have to put any constant, so we'll put it as c1, and 2 is also constant, so we'll just put 2 to make easy for solving it. Now here we have 2 in the denominator, so it will get cancelled. And bring this y square here, so we get x square minus y square is equal to c1, which is solution 1. Now we will take fraction 1 and 3. Here we taken here y, and here also y is there. So this y and this y will get cancelled. We'll get this. Bring the x here, bring z here, we'll get this. On integration, we get this. And this c2 by 2 is integral constant. Bring this. So here all the 2 will get cancelled. Bring this z this side, which is equal. Then we'll get x square minus z square is equal to c2. This is solution 2. Now we got solution 1 and solution 2. Hence we'll get general solution is phi is equal to solution 1 comma solution 2. Case 2. Second independent solution is obtained using first solution. Here only one pair is integrable. So we have to integrate it, get the solution. That solution we have to substitute to find second solution. Let's see some examples. This is the equation given. This equation is not in the form of this. So we have to convert this equation in this form. To do that, we have to multiply px with this term and then minus qy with this term. So after multiplying, we get this equation which is in this form, and we'll name this equation as equation 1. Now we have to find auxiliary equation, that is dx by coefficient of p. Here coefficient of p is this value, so we'll write it here, is equal to dy by coefficient of q, which is this, is equal to dz by coefficient of this, by this value, x to the power 4. So this equation we'll call it as equation 2. We'll take fraction 1 and fraction 2. When we compare, this term and this term will get cancelled, z and z will get cancelled. So we are left with this. This on integration will get integration of 1 by x is log x is equal to minus 1 by y is log y plus our integral constant. Bring this side. So we'll have log x plus log y. So according to the property of log x plus log y will become log xy is equal to this log c1. This log and this log will get cancelled. So we'll get xy is equal to c1. Now we'll take a 1 and 3. So here when we see, here this x and this one of the x from here will get cancelled, and so here we'll have x cube. Bring this x cube here and bring this term here. So x cube dx is equal to this term into dz. Here dx is given, here dz is given. So all the terms should be in the terms of x and z. Only then we can integrate. But here we have y term, so it becomes difficult to integrate. So we substitute the value here. So from solution 1 we know xy is equal to c1. So here instead of xy we'll substitute c, in the place of xy we'll substitute c1. So we'll get this equation. Now this simplifying this term. So this term is same, x cube dx is same, is equal to, simplifying this term, z into z square becomes z cube. The z into plus z into c1 is z c1. Okay, now integrating it. X cube becomes x to the power 4 by 4 is equal to this z cube becomes z to the power by 4 plus this z becomes z square by 2. C1 remains C1 plus we have to have one integral constant. We have kept it as C1. This means here we have to so put the value of C1, which is xy. So we have put the value of C1 xy. Now we have to take LCM. After taking LCM, this we can get rid of this 4 from the denominator, and we get x to the power 4 is equal to z to the power 4 plus 2xyz square plus 4c. This 4c is constant. We can write it as C2. Bring all this other term this side. So we get x to the power 4 minus z to the power 4 minus 2xy z square. This is solution 2. So general solution is equal to psi of solution 1 and solution 2. Solution 1 is xy and solution 2 is this. So this is the required general equation. The next example. This is the equation given. This equation is in the standard format. And now we'll get Lagrange's auxiliary equation, that is dx by coefficient of p, which is xy, is equal to dy by coefficient of q, which is y square, is equal to dz by this term. Now we'll take term fraction 1 and fraction 2. So we get this. Here this y and one of the y from here get cancelled. So we are left with dx by x is equal to dy by y. On integrating it, we'll get 1 by x is log x, 1 by y is log y, plus 1 integral constant. We'll take it as log c1. Bring this here. So we'll get log x minus log y is equal to log c. Log property, log x by y is equal to log c. This log and this log will get cancelled. So we'll have x by y is equal to c1, which is solution 1. Now taking fraction 2 and 3. dy by y square is equal to dz by zxy minus 2x square. Here dy and dz is given. So all the term should be in term of y and z. But here we see x term. So it becomes difficult to integrate. So this x term needs to be substituted. From solution 1 we know x is equal to y into c1. So we'll put the value here. So here dy by y square is equal to dz is there. Z into the value of x as yc1 and here again yc1 square. Now after putting this, we see this y square, and here y into y is y square, so this y square and here y square. So all this y square get cancelled. So we have dz by, here c is common, so we'll take c out. We get z minus 2c1. Bring this c1 here. So c1 dy is equal to dz by z minus 2c. Now we have to integrate this and we have to integrate this. When we integrate, this is constant and integration of dy is y. And here integration of z is integration of 1 by z minus 2c is log z minus 2c1. Plus we have to have one integral constant. Here we'll have c2 as integral constant. Now value of c1 we have to put. C1 is equal to x by y. So c1 is equal to x by y. This y and this y will get cancelled. Is equal to log z minus this c1 value x by y. Plus this is c2 will be there. Now here we have x. So x, this whole term we bring it here. So it becomes minus log z minus 2xy. We are bringing whole of this term this side. And this c2 remains here. So this is the required solution, which is solution 2. Now we got solution 1 and solution 2. We have to put solution 1 and solution 2 in general equation. We get this, that is phi of solution 1 is x by y and comma, and solution 2 is x minus log z minus 2 x by y. So this is solution 2 and this is the required equation.